This is May-June 2024, paper 1-2. Let's get through with this paper. So he says, underline the quantity that is not an SI base unit. So current is a base unit, and your length is a base unit, time is a base unit, charge is not, because Q is equal to IT, that would be ampere seconds. It's not a base quantity. The next question is that this is the solar panel's dimensions. Okay, fine. So light is independent, light is incident normally on the solar panel. Okay, fine. So it's receiving 750 watts of power on that solar panel. He wants you to calculate the intensity. So first, let's remind ourselves with the formula for intensity, that is I equals to power divided by cross-sectional area. So power over here is 750 watts that is being received, and the cross-sectional area over here is 1300 millimeters multiplied by 1300 millimeters. Now please be advised that area has to be in meters, because we have watts per meter square as the unit of intensity. So this will become 1300 multiplied by 10 raised to the power minus 3 to convert back to meters as millimeters, and then 1300 multiplied by 10 raised to the power minus 3, again going back from millimeters to meters. The answer of this question, or this, will be 443 watts per meter square. So this should become 440 up to two significant figures. Then we have the percentage uncertainty question. He says that on the incident power there is an error of 3%, but in the length there is an error of 5%. He wants you to find out the percentage uncertainty in the intensity of light. So the intensity of light, the formula goes something like this. This is actually power divided by area. So the percentage uncertainty becomes delta P divided by P plus delta A divided by A. And since we do have the calculation of area in terms of this 1300 multiplied by 1300, so we can open this up as at least 2 times, or if you want to look at it from this perspective, this goes something like this. That area, cross-sectional area, is length multiplied by length, which becomes L square. So this becomes 2 delta L divided by L, right? So in place of A by A, we will be using 2 delta L by L. So what does that become? So delta I over I is equal to delta P divided by P plus 2 times delta L divided by L. Now, do we have an answer for delta P by P? Yes, it has already been calculated or given to us as 3%, because the whole bracket will be multiplied by 100. So this fraction is already being multiplied by 100, should give you an answer of 3%. Now, it's a matter of only calculating delta L by L. So in order for us to do that, let's do that separately. So this becomes 2 multiplied by delta L, which is 5 as the error, divided by 1300, then whole multiplied by 100. This comes out as 0.769%. If you add a 0.769% in this, this becomes 3.769%. So this comes down to 3.8%. Moving on to question number 3, he says the useful power output is 160 watts. We are supposed to find out the efficiency of the solar panel. So we understand that from the solar panel, the input power is at least 750 and the output is only 160 watts. So the total input is 750 and the useful output is 160. So we are investing 750, but we are only getting back 160. So multiplying this with 100 gives us the answer as 21.3%. So this is going to come out as 21%. The next question is, he says that if the power output is same with shorter sides, let's say we are using a smaller solar panel as opposed to the previous solar panel, we are still getting 750 watts. We are still getting 750 watts as the sunshine, but this is giving me 160 watts and this is also giving me 160 watts. So which one has a greater efficiency? Now we can very well see, at least in terms of logical answer, that a smaller area is giving me the same output as opposed to a larger area, which means that this solar panel with smaller sides is more efficient, is converting that power more efficiently. Because imagine if I had the same surface area, but if I had used the same number of panels as this surface area, this would have been producing, or this would be producing more power by receiving 750 from the sun. So using this idea, using this logic, we will say that the shorter sides, first we state which one has a higher efficiency. Shorter side has a higher efficiency, right? They have the same output. They have the same output, or you can say they are doing the same job, but with smaller area or cross-sectional area. Hence, its efficiency is greater, or efficiency is greater. It's producing the same power by intaking the same amount of power from the sun, but giving output exactly the same by lesser area or by using smaller area. Question number 2 calls for a terminal velocity question. We can see the graph. We can see very clearly from the graph. Now, then he says that what's the terminal velocity? Now we understand the terminal velocity is the point when the object attains constant velocity. So at this point, there is a terminal velocity, and that value is 39. So this will be 39. You can count the number of boxes. You can zoom in and count the number of boxes yourself. And then we have, by drawing a suitable line. Now a suitable line, of course, is referring to the tangent line. Determine the acceleration. We understand that the velocity time graph, in velocity time graph, the gradient represents the acceleration and the area represents the displacement. So for the tangent at the certain point where he's asking us at t equals to 9. So at exactly t equals to 9 seconds, which is going to be at this point. No, probably 2 boxes behind. Yep. So this will be 2 boxes behind. Please count the number of boxes accurately. And exactly at this point, then we will draw a tangent. Now make sure that the tangent actually goes to both edges, and the angle theta, at least by inspection by eyes, should be exactly the same. That will enable you to draw the best or the perfect tangent. Again, now once you've extended those lines, you can pick up any coordinate or any 2 coordinates from this line and then mention those coordinates over here, as I've done. So for me, the coordinates were 17, 44. They could be different for you. So 1.5 into 25. Then you mention the formula for the gradient, which is going to be acceleration equals to delta y divided by delta x, as y2 minus y1 divided by x2 minus x1. Please highlight the procedure completely and then replace the values, which is going to be 44 minus 27 divided by 17 minus 1.5. So the acceleration comes out as 1.096 meters per second square. You can use this space over here as well. So this comes out as 1.1. My answer is 1.1 meters per second square. Your answer could be different. As is mentioned in the marking scheme, there is a range of answers that are acceptable. So part B, he says skydiver has a mass of 68. The upthrust is negligible. Okay, fine. And there is a drag force of 1800 newtons at time t1. So determine the magnitude of acceleration. Okay, fine. So we have F equals to ma. What are the forces acting on the object? So there is the weight of the object, which is pulling it down. That should be mg minus the drag, which is 1800, into mass of the object is 68, into acceleration, which we want to find out. So mass is 68 multiplied by 9.81, right? Minus 1800 equals to 68 into a. Now this 1800 is much greater than that multiple, which is this one. So the answer comes out to be a negative answer, which is negative 16.7 meters per second square. So the acceleration comes down to negative 17 meters per second square. So this will be, as it is acceleration, we'll have to mention the negative sign, which is going to be minus 17. And as for the direction, since the negative sign is acting against, or it is acting opposite to the movement, it is deceleration. So the direction of the deceleration will be upwards. Why? Because we can see very clearly that the drag, which is 1800, is greater than the weight, which is mg, that is 68 into multiplied by 10. Even if you take 10, this will be 680 newtons, which is less than 1800. So the upward forces are greater. That's why the direction is upwards. Moving on to the next part, we have the parachute is fully open at t2. At time t3, it reaches constant velocity, the terminal velocity 5.7. Describe and explain the variation with time, the magnitude of acceleration between t2 and t3. You see, at t2, he opens the parachute completely. So the moment he opens the parachute, right, till the moment t3, the acceleration will be changing. But how is it going to change? Let's discuss that. So the speed decreases, and as the speed decreases, because we have a deceleration, right, the drag also decreases because we know that they depend on each other, right? They're directly proportional. And as the drag also decreases, so after T2, the resultant force also decreases. Now, since the resultant force is decreasing, it eventually becomes 0 at T3. Now, when the resultant force becomes 0, the acceleration also equals 0 at that point, right? And between T1 and T2, the acceleration is less than 9.8, right? And between T2 and T3, the acceleration is again less than 9.8, but greater than 0. After T3, the acceleration has become equal to 0. That is how this graph actually represents the terminal velocity situation, right? Okay. Then he asks you about the change in momentum from T1 to T3. So the change in momentum is equal to final momentum minus initial momentum. So since that is mass into V minus mass into U, mass is common. Let's take m on the outside. So this becomes final velocity minus initial velocity. Now the final speed is 5.7. So in place of mass, we have 68. The final speed is 5.7. The initial speed at which it was falling, or terminal velocity, was 39. So after multiplying this, you get minus 2264 Newton seconds. So this becomes negative 2300 Newton seconds. Question number 3 suggests lightning occurs when the charge builds up. Okay, fine. There is this much amount of current for this much amount of time. How much charge is being transferred? So Q is equal to I into T is equal to 3.3 into 10 raised to power 4, 2.6 into 10 raised to power minus 5. So when you calculate this, this comes out as 0.858 coulombs. That becomes 0.86. In the next question, he says that the total potential difference between the ground of the sphere is 3 into power 7. Calculate the average power. So power is equal to current into voltage. Now the current in the previous part is given to us as 3.3 power 4. So let's replace that value. 3.3 into 10 raised to power 4. And the voltage is given in this part, which is 3 into 10 raised to power 7. Once you calculate that, you're going to get the answer as 990 into 10 raised to power 9 watts. Now we know that power 9, this power 9 is actually for the power of giga, which is capital W. So this is going to be 990. Okay. All right. The next question, he says that the lightning rod is connecting with a length of 95 meters. Okay, fine. In the next question, he says, determine the radius of the lightning rod. The resistance is given to you. The resistivity is given to you. So the formula is resistance is equal to rho L over A. The resistance is 9.6 ohm. The resistivity is given to you as 1.7 into 10 raised to power minus 8. The length is 95 meters as given in the previous part, which is over here, right? So we have to figure out the cross-sectional area, right? So we figured that out, or we figured out the cross-sectional area as okay, so whatever that may be, we can write down pi r squared in place of that. Now taking r square over to the other side, bringing 9.6 over here, taking the under root because it's a square, the radius comes out as 0.23 into 10 raised to power minus 3. So this becomes 0.23 into 10 raised to power minus 3. Then he says that the radius of the copper lightning rod is doubled. The radius is doubled. It is now thicker than as compared to before. With no change in length, what happens to the resistance? You see, the radius and the resistance. So resistance is inversely proportional to cross-sectional area, right? It is inversely proportional to that, and we know that this is equal to pi r squared. Pi is a constant, so what we are left with is resistance being inversely proportional to r squared. Now, if you double this, for example, mathematically speaking, if this is 2r, taking a whole square makes it 4r. So the resistance is now inversely proportional to 4 times r. If the radius is doubled, the whole resistance reduces by a factor of 4. So we're going to write down that resistance reduces 4 times or by a factor of 4. In the next question, he says that a section is removed. This is the length. This is the tensile stress, force over area. And this is the length. And this is the Young's modulus. He says calculate the extension of the section. So the formula for Young's modulus is equal to stress over strain, right? Which is force over area divided by the extension divided by original length. Now, since every value is given to you in full format, we don't need to use this formula. We can use this one. So the Young modulus is 1.3 into 10 raised to power 11. The stress given to you in the question is, the tensile stress is 1.9 power 6. So 1.9 into 10 raised to power 6 divided by the strain. Take strain over there and bring the modulus over there. So strain is calculated as 14.6 into 10 raised to power minus 6. Now we want to find out the change in length or the extension. So just equate strain as the extension divided by original length. Do we have an original length? Yes, we do. That is 0.12. And we have the strain as well. So we can find the extension. So this is 14.6 into 10 raised to power minus 6 equals to extension divided by 0.12. Take this over there to multiply. The extension comes out as 1.75 into 10 raised to power minus 6. So this becomes 1.8 up to two significant figures, power minus 6. Then we have question number 4. He says that the spring is compressed by some external force. Somebody else has done this for us. And now it is being held in equilibrium. Everything is balanced now. He says the spring obeys Hooke's law and spring constant 29. Calculate elastic potential energy. So that elastic potential energy formula is half kx square. So 1 over 2 into the spring constant, which is 29, and x square, which is this, right? Which is the amount of compression the spring has experienced, which is 8 centimeters, 10 raised to power 8 into 10 raised to power minus 2 whole square. Don't forget the square. So this answer comes out as a very small answer, 0.098928. Yes. So this becomes 0.093 joules. The next part says that the spring is released, expanding quickly, and it comes back to the original length, which means that if the spring actually comes to this point, the spring has expanded to come at this point, and now the ball is released to move forward, right? Okay. Calculate the increase in gravitational potential energy. Okay, a question that looks complicated, but it is not. So previously the ball is located at this point. Now the ball will be located at this point when it actually moves from this point to this point, right? So we can make a small triangle in this location. We can see that this length is covered and this would be the triangle, right? We are only interested in this height h, or the perpendicular height, because of the gravitational potential. So let's make the triangle over here. It goes from this point to this point. We are interested in h. This is 8 centimeters. This is 15 degrees. So h should be 8 sine of 15. But of course, this is divided by 100 to make it into meters. So applying the formula of mgh, we have the mass of the ball as 4.5 into 10 raised to the power minus 2. So this is 4.5 into 10 raised to the power minus 2 into 9.81 into height, which is 8 into 10 raised to the power minus 2 because of this 100 division, and then a factor of sine 15. Once you calculate this, your answer is going to come out as 9.14 into 10 raised to the power minus 3 joules. Now, so this becomes 9.1 into 10 raised to the power minus 3. Now, for that perspective, if I want to write this down, this will be 9.3 into 10 raised to the power minus 3. Okay. It will be minus 2. Yeah, this will be minus 2. And this comes out as minus 3. So this increase in gravitational potential is actually lost to the surrounding or to the system. Will we be able to get it back once it falls down? Yes, but not right now. Now, why have I made this statement? Because that's a build-up for this part. So the ball leaves the spring when the spring reaches its original length. Okay, fine. Assume that all the elastic potential energy, the spring, is transferred to the ball. Calculate the speed of the ball. Now, first we need to understand what's happening in terms of energy. Which thing or what thing brought the energy into the system? Who has consumed the energy, and where is the extra energy going to go? So who brought the energy into the system? So energy given by the spring is equal to, or will be utilized by, work done against gravity to move the ball upwards, plus energy given to increase the speed, which is the kinetic energy of the ball, right? So we need to find this first. What is the energy left for the ball? So we have supplied 9.3 into 10 raised to the power minus 2 joules from the spring. It converted 9.1 into 10 raised to the power minus 3 joules into gravity as mgh, and the remaining will be kinetic energy. Now that comes out, or the kinetic energy comes out as, by subtracting them, of course, we take this over there, it gets subtracted. So we get 8.4 into 10 raised to the power minus 2 joules, which will now be equal to half mv squared. This is the speed that we want to find out. So 8.4 into 10 raised to the power minus 2 equals to 1 over 2 into mass is 4.5 into 10 raised to the power minus 2 into v squared. Don't forget to take the under because this is a square, please. Don't forget about that. So velocity comes out as 1.93 meters per second. This will be 1.9 after two significant figures. The C part is in terms of moments. He says that the force F has a value of 1.7 as mentioned over here. He says the whole system is in equilibrium, right? So what is the value of D if the whole system is in equilibrium? So no problem over here. Just try to figure out what's the clockwise and anti-clockwise moment. If this is the pivot, this force will cause the anti-clockwise moment and the ball will cause the clockwise moment, right? And everything is balanced out around the pivot or around the pivot. So simply put, F into D is equal to around the pivot into F, which is going to be mg of the ball multiplied by its own distance from the pivot, right? So let's write this down. So this is going to be 1.7 into its distance, which is 2 centimeters. So 2 into 10 to the power minus 2 equal to, in equilibrium, by the ball, which is over here. Now, can we convert the mass of the ball into a force? Yes, by using mg. So 4.5 into 10 to the power minus 2 mass into the value of g, which is 9.81, into distance, which is a value of d, which we don't know. So d comes out as 7.7 into 10 to the power minus 2 meters. So 7.7 into 10 to the power minus 2. Then we have, he said that the force F decreases. Now, if you decrease this force, if the force decreases, then the anti-clockwise moment starts decreasing. If this moment starts decreasing, then this moment starts dominating. This will be more than this side. So it will start rotating clockwise. It will favor the clockwise direction. So he says state the direction of the resultant moment. So this will now be clockwise direction. All right. Okay. Then we have question number 5. It says states Kirchhoff's second law. This is based on energy, right? So sum of all EMFs is equal to the sum of all potential differences in a closed loop. In a closed loop or a closed circuit. Basically, this is an energy conservation principle. He says that all the EMFs will be equal to all the potential difference. Another way of saying that is the sum of EMF with the potential differences will be equal to 0, right? So that is what this law is about. It's about energy conservation. All right, so the next part is, he says that we have a component X and Y. They are connected to a 9-volt battery. It's a series circuit. And now we have a graph for this, for the thermistor, which is Y. Okay, X is a variable resistor. We don't know about that. So the current in the circuit is 1.1. The potential difference across Y is 4. So Y is consuming 4 volts. So by the series circuit, we understand that 5 volt will be used by X. Okay, because it's a potential divider circuit. The voltage divides in a series circuit, right? So he's asking me the resistance of X. No problem. So that will be V equals to IR. Since it's a series circuit, the current will remain the same, which is 1.1 into 10 raised to the power minus 2. Resistance of X, we don't know, but what voltage is it consuming? It's consuming 5 volts as calculated previously. So the resistance of X comes out as 454. Yeah, so 454 point something ohms, which is going to get to 450 ohms. He says the temperature of Y is changed to 190. The resistance of X remains unchanged. We are not changing X, but we're going to change Y. He says determine the new potential difference across Y. No problem. We have to go back to use the graph for this. So when we come back to 190, this is approximately at this location. You see that at 190, this is the value, which is actually 25 ohms. 25 ohms, right? So today, by new standards, what has happened? What has changed? So today, this is still 450 ohms, but the thermistor has come down to 25 ohms. Now he's asking you, what is the new voltage of this system? So we can use the potential divider rule. That would be the resistance of which we want to find the voltage of, 25 divided by the whole circuit, 450 plus 25, multiplied by the 9 volts that we are sharing among them. So once you've done that, your answer comes out as 0.473, which is 473 volts. So if you just narrow it down and copy that method over here, we come down to 0.47 volts. Now the next part, he says the resistance of X is increased. Now what is X? The X component is this one, right? And the other component is not disturbed. So it is still maintaining a resistance of, or you can say it's maintaining its own resistance of 25 ohms, but we're increasing the value of X, or increase the resistance of X. Previously, students used to justify this in terms of voltage, but today he's bounding you to justify this in terms of current. You see, both components are connected in series to each other. So first we have X, then we have Y. Y still has a resistance of 25 ohms, but the X, previously 450 ohms, is now going to get increased up to 500, 700, 1000. We don't know. So what's going to happen to the circuit, and what's going to happen to the potential difference across Y? He wants you to find out the effect across Y. No problem. First, you need to tell him what happens to the current. So the total resistance increases, because if you increase this one, then the total resistance is simply the addition of R1 plus R2 for a series circuit. The both resistors get added together. The total resistance increases and the current decreases. The current in the circuit decreases, right? Now, since according to Ohm's law, V equals to IR, when the current decreases, voltage also decreases. So for Y, the voltage will be less as compared to before. Why? Because the current value, or the I, is decreasing. So mathematically speaking, R was not changing, I was decreasing, so the voltage will also decrease. So this is what he was expecting from you. You can write this down in a statement form. Okay. Question number 6 is from diffraction light, right? So this is a diffraction crystal. So the formula for that is n lambda equals to d sine theta. That is what I do generally. I write down the formula for diffraction grating. At least it separates us from the double slit question. This is light from a single frequency is incident. Okay, fine. He's given us the lambda. He's given us the diffraction grating separation, which is the value of d. He's asking you to determine the total number of bright fringes. This is basically an MCQ question, which he's asking you in terms of P2, but no problem, no worries. What he's trying to ask you, he says that what are the total number of fringes? So at the center, then over here, then over here, then over here. What is the maximum number of fringes or bright fringes which will be observed by the observer, right? So for that, what we need to observe, what we need to accept is that the absolute maximum, or the absolute largest case, could be, with comparison to the central fringe, which is at n equal to 0, what could be the widest angle? So the widest angle would be 90. So we would have to assume, for the sake of this question, that sine theta is 90, because we want to find the total number or the maximum number, right? So based on this idea, let's write down the formula n lambda equals to d sine theta. So n is what we want to find out. Lambda is 520 to 10 raised to power minus 9. D is given to us 3.8 into 10 raised to power minus 6. Sine theta will be taken as sine 90. We know sine 90 is equal to 1. So basically it's just division of this number with this one. So n comes out as 7.3. Now we know this, that it has to be an integer and it has to be rounded down. So n will be equal to 7. Now, what do we mean by this? So there will be 7 fringes on the left side, 7 fringes like this one, bright fringes on this side, and 7 fringes exactly on the same angles as compared to center on this side. So how many number of fringes are there? So 7 plus 1 at the center, which is at n equal to 0. So this will be 7 plus 7 plus 1, which becomes 15. So the number of fringes will be 15. Now, to put it into plain perspective, or to look at from another angle, notice that if you use this 7 to calculate the angles by using the same formula again, put 1 in place of n, then 2, then 3, then 4, and see what sine theta do you get. So these are the angles that we're getting. So the absolute last fringe that we considered is going to be formed at 73. So the 7th fringe, n equal to 7, was actually at an angle of 73 degrees, right? After this, there was not a possibility for the 8th fringe to be formed. That's why we round these numbers down. Even if it had been 7.9, it will be considered as 7 because 7.9 calls for exactly 90 degrees angle. And we know that orders are an integer number. They are not decimal. So this 90 is not possible at 7.9. So it can only either be less than 90, which is at 7, right? So this is just a table to tell you that 7 we selected actually produces an answer. 8 does not produce an answer, which means that 7, when we rounded it down, the logic was right. Okay. Okay. Question number B. He says that the light is replaced with the red light of a single frequency. Now, lambda wavelength of red light is 700 nanometers if we compare it with the yellow light in the previous part. He says state whether the frequency of the red light is greater than or less than. Okay, no problem. According to V equals to F lambda, if you change the relationship between F and lambda, the value of V does not change because that's the speed of light. It is going to remain constant. But if you change F, lambda is affected inversely, right? So in comparison to the orange or yellow light in the previous part, which is 520, the wavelength has increased. So if the wavelength has increased, the frequency will decrease. They go in the opposite direction. And if you don't understand this, no problem. So V is divided by F equals to lambda if we take F over there. So if lambda is increasing, then F is decreasing, right? So we will write down that the frequency is less than the yellow light of 520 nanometers. Then he says state explain the effect of changes in the number of bright fringes formed on the screen. Okay, no problem. So based on the formula of lambda, n lambda equals to d sine theta, he's asking us about the number of fringes. Are we changing something else? Are we changing the diffraction distance between the laser cuttings? No, we are not doing that. Are we expecting a different angle? No, we are not expecting a different angle. So what's going to happen? There's a relationship between n and lambda. So in terms of lambda, it is inversely proportional to the number of fringes on the screen. So if I increase the wavelength, it is increased from 520 to 600 or 700 to make it red color, the number of fringes will start decreasing. So this is what you're supposed to mention in terms of a statement. You can mention this relationship and then you can just simply say that they are inversely proportional to each other, and increasing the wavelength decreases the number of fringes on the screen or produced on the screen. This question is from radioactivity. He says particle Q and particle are composed of one quark and one anti-quark. So we only have one family that has two quarks. That is the meson family, which falls under the category of hadrons. So we have hadrons, and from hadrons we have baryons, and we have mesons. Baryons have three quarks and mesons have two quarks, one quark and one anti-quark. And baryons, we have done that in our previous syllabus. That is actually protons and neutrons that have three quarks, right? So he says state the name of the family. So that is mesons only, or meson, right? Then we have, he's going to ask you about Q and R. He says the charge is -1 and 0. He says that the first quark is strange. So the strange charge is -1/3. And the second charge has to be an anti-quark, or it has to be an anti-charge of this one. And to make a -1 charge, we need a charge of -2/3e, right? So if you add them together, if -1/3 and 2/3 are added together, they become -1e. So we predicted the charge correctly, but now we have to recall from memory who has -2/3e. So an up quark or a top quark or a charm quark both have +2/3. But since this has to be a -2/3, we would have to choose the anti-versions of this one. So this will either be anti-up, it will either be anti-top, or it will either be anti-charm charm quark, right? Okay, so the next part, he says that the charge is anti-up, so it has to be -2/3e, and we want a 0 overall charge. So it has to be someone that has +2/3e. So that when you add them together, the overall answer becomes 0. So from our memory, we have this as up, we have that as charm, we have that as top. Now, since this is anti-up, I would prefer up as the charge so that one becomes quark and one becomes anti-quark, right? Okay.